Okay, so here are some extra examples for section 8.7 that we went over in class in case you missed class or just forgot to do something. So component form of a vector. Basically what you treat component form like is it looks like an ordered pair, like you're going to graph something, but all it does is it describes the path. So I put these little guys around the outside of it here, the kind of like greater than and less than symbols. And this tells you your left or right movement. This tells you your up or down movement. Okay, so we start at Q and end at P because that's where the arrow's going. So the question is, how did I get from Q to P? Well, I went left 1, 2, 3, 4, 5, 6. So it's -6 movement that way. And then I try to think, did I go up or down? And no, I didn't go any up or down. So it's -6, comma 0. So not terribly exciting, but that's the component form of the vector telling me what happened. You started at Q and you went left 6, but didn't go up or down any at the same time. Now, where things get trickier at are these problems here. We got to find the magnitude and the direction of each vector. So the easy way to do this is just to start off and imagine you're at 0, 0, and you're moving the way this vector tells us to, which is 2 right, down 4. So I'll go right 2, down 1, 2, 3, 4, and it takes me actually to this point right here. Okay. So the magnitude's easy, because that's just realizing you're working with the right triangle. Okay. So if I kind of just, almost think this out as a triangle, it's 2 for one side, it is 4 for the other. So this is the leg, this is the leg. So magnitude is also the absolute value of this guy. That's just the Pythagorean theorem. We're going to call it m equals 2 squared plus 4 squared. I know it's negative, but I don't care. Think of it as the side length of a triangle. Okay, so m, and it's actually m squared then. 4 plus 16, which is 20. Take your square root. Root 20 is really 2 root 5 as an exact answer, but as a decimal approximation, root 20 is somewhere between 4 and 5. Uh, 4.5, let's say. And again, magnitude is just the length. So this vector is 4.5 units long. Now here's the trickier portion. It's figuring out the direction, which really what they want to know is they want to know the angle. And that angle we want to know is the angle right here, because that's the angle I can solve for. Well, in order to do that, I have to again realize this is a little right triangle here with side length of 2 and 4. I'm looking for that guy. So that's opposite and adjacent. So the tangent of that angle is 4 over 2. I'm going to do inverse tangent of 4 over 2 to get that angle. So second tangent, 4 over 2, which is really just 2, but it doesn't matter. 64 degrees, let's say. Okay, 64 degrees. Now, here's the tricky portion of this. North, west, south, east. I can describe this two ways. I can think of it as respect to the horizontal, which is the east, and it's 64 degrees south of the east. So for the direction, I don't need this anymore, it's just in the way. I am 64 degrees south of east. Okay, because I've gone, here's the east line, I'm going to go 64 degrees south. The other way I could describe it is if I think of how am I with respect to the vertical. Well, that's south. Okay. So the question is, how many degrees is this? Well, if this is a right angle here, 90 minus 64 gives me 26 degrees. So it's 26 degrees this way. So I am 26 degrees east of south. So I have a couple different ways I could describe the magnitude for this. Okay, and that's always the hardest part, is doing that. Just have the direction, not the magnitude. Direction is always difficult to sort out. Okay, now the last couple examples are kind of common sense examples, okay. And I'll show you how it works out graphically for both of these, because this is something that the book doesn't really cover too much. But number 9 says add C and A together. Well, A is -4, 1, C is 3, 5. If I were guessing, I would just say, hey, let's look at this as far as we look at the kind of component form of the vectors. And this tells you I'm going to go left 4, up 1, then right 3, up 5. Well, negative 4 plus 3 is negative 1. 1 plus 5 is 6. So I should be kind of saying something like, oh yeah, you're going to go left 1 and then up 6. Well, graphically, that's kind of what happens. Okay. If I start at, like, let's say the origin. A says go left 4, 1, 2, 3, 4, up 1. So this is A. A is telling me to move like this. I know it's not terribly straight, but sorry. And this is the answer we got. And then the blue one, which is, oh dang it, that was A. This should have been, oh, too late now. This is A. This is C. I did it kind of backwards. It's A plus C, not C plus A. Same thing. But C says, okay, you've done that. Now go right 3, up 5. So here's right 3. 1, 2, 3, up 1, 2, 3, 4, 5. Which is off my screen, really, off my grid. But if I look at how I traveled from here to here and just went that straight direction, which is what addition means, I just went left 1, up 6. That's what that vector tells me to do. Now, number 10, okay, number 10, it says 2b minus a. Well, 2b is what you would think. Just double b, which then would be negative 2, negative 6. Okay. And then negative a, which is what they're asking us to do here, is what you would think of it as well. Hey, just do the opposite of a, so 4, negative 1. And then just add them together. And when you do that, you're going to get 2, negative 7. Okay. Now to visually show how that works out, okay, B is left 1, down 3. So here's left 1, down 1, 2, 3. Then left 1 more and down 3 more. 1, 2, 3. Okay. So here is 1b, here is 2b. Then negative a, because it means minus, means negative a, is really the opposite of negative 4, 1. That means right 4, down 1. So go right 1, 2, 3, 4, down 1. Okay. Well, if I think of this in terms of how I got from here to here, and now I'm just looking at basically what if I went from here to here. Hey, look, right 2, down 7. No, it doesn't show up there. Here we go. Right 2, down 7. What's this guy telling me to do? Right 2, down 7. Okay. So there are kind of some of the run through basically from section 8-7.